Welcome to Minute Profinet. In today's video, we're going back to basics with a very general but common question: what is Profinet? It was the topic of our very first Minute Profinet video, but this time, a bit more focused and with some further explanations.
Profinet is an open industrial Ethernet solution based on international standards. It is a communication protocol designed to exchange data between controllers and devices in an automation setting. The PI organization introduced Profinet in the early 2000s, and by 2021, it is the most well-adopted industrial Ethernet solution in the world with over 40 million nodes installed. Since Profinet is an open standard, hundreds of manufacturers have developed Profinet products such as PLCs, PACs, drives, robots, proxies I/O, diagnostic tools, and much more. Profinet defines cyclic and acyclic communication between components, including diagnostics, functional safety, alarms, and additional information. To link all of those components, Profinet employs standard, unmodified Ethernet for its communication medium. Industrial, ruggedized Ethernet cables connect Profinet components within a network, allowing other Ethernet-based protocols to coexist within the same infrastructure. Besides Profinet, you can employ other Ethernet-based protocols to complement the network, such as OPC UA, SNMP, MQTT, or HTTP. This video will cover how Profinet works in terms of mechanisms and an overview of the Profinet network. Industrial automation environments often require high speeds and deterministic communication. Deterministic communication means delivering messages exactly when they are expected. Profinet is a communication protocol that lives at layer 7 of the ISO OSI model, the 7-layer model that generically describes the abstraction layers of a communication system. Profinet must ensure messages are delivered within the appropriate speed and determinism depending on the task. Not all applications require the same performance. For example, loading configuration data for a process instrument can take several minutes without affecting production. On the other hand, a communication delay of just a few milliseconds between a PLC and a high-speed VFD can significantly impact the process. Profinet can employ TCP/IP or UDP/IP based communication for non-time critical tasks, such as configuration and parameterization. But, due to the potential latency and delays associated with IP-based communication, this method is unsuitable for time-critical tasks. Profinet employs a real-time channel to deliver data in a fast and deterministic fashion for time-critical applications. This is how it works. All Ethernet frames have a field called an ether type, which indicates the kind of data encapsulated inside. Profinet real-time communication is set to have an ether type of 8892. Upon arrival at a Profinet station, the data is directed to the application immediately. The Profinet data goes directly from Ethernet, layer 2, to the application, layer 7. It skips the TCP/IP layers entirely and avoids the variable time it could take to be processed as such. Thus, communication speed and determinism improve significantly. Profinet Real-Time fulfills the requirements of the vast majority of time-critical applications. The overall performance will depend on network design, but generally, cycle times of 512 milliseconds down to 250 microseconds can be achieved. No special hardware or configuration is required to use the Profinet real-time mechanism, as all Profinet products are equipped with this capability. For increased performance, you can employ Profinet IRT. Profinet IRT eliminates variable data delays by enhancing the rules used to switch Ethernet traffic and creating special rules for Profinet traffic. It fulfills all synchronization requirements and allows deterministic communication with cycle times down to 31.25 microseconds and up to 1 microsecond of expected delays, also known as jitter. Profinet IRT is optional and only required in specific high-performance applications such as packing machines and printing presses. When building an industrial network with Profinet, you will employ 3 major pieces of hardware: controllers, devices, and general infrastructure. You can select Profinet products from a variety of suppliers. It is not a requirement to implement devices and controllers from the same manufacturer. Be strategic when choosing the controller, as the engineering tool you will use to configure the whole network is determined by the controller. Cables, connectors, and switches do not need to be specialized for Profinet. You can employ standard Ethernet cables to build the network. However, industrially graded cables are the default for most installations, as using standard Ethernet cables in challenging factory environments can cause many issues. Commercially available Ethernet cables are not industrially graded. They can break and damage easily and can ultimately compromise the network infrastructure and signal quality. In Profinet installations, you can also employ simple, unmanaged switches as long as they meet the minimum specification of 100 megabit per second full duplex. Still, it is always recommended to use rugged components that can withstand rough environments. Industrially graded components reduce downtime and maintenance requirements dramatically. The most common connector type for Profinet is RJ45, but M12 connectors are also used in high exposure environments and BFOCs for fiber optic applications. Profinet users have flexibility when designing a network. There's a variety of topology options: line, star, tree, and ring. You can implement these topologies by using either dedicated switches or devices with 2 ports that include a built-in switch for daisy chaining. In terms of media options, Profinet is compatible with copper and fiber optic, wired media, and wireless via Bluetooth or Wi-Fi. Configuring a Profinet network is not complicated. Each controller has an associated engineering tool to configure the network. Even though engineering tools vary across manufacturers, there's a common process for Profinet configuration. Follow the link in this video's description to take the next step and watch a live demo of how to configure a Profinet network.
This video gives you a basic understanding of the Profinet protocol, but there is much more to learn if you plan on working with Profinet regularly. Follow the links in the video description to 2 free and useful resources to get started: a comprehensive webinar on the basics of Profinet and a free ebook on Profibus versus Profinet. Please feel free to comment below, share your feedback, and ask any questions. And as always, thank you for watching.